Hi, welcome to part 17 of the video series about laws of motion. In the previous question, we learned how to calculate the tension force between two objects which are pulled on a rough surface. In this question, we will learn how to calculate the action-reaction forces between two objects. On the screen, we can see two objects of mass 2 and 3 kgs respectively. A force of 40 newtons applied on 2 kg object is trying to push the system to the right. We are asked to calculate the force the 3 kg object exerts on the 2 kg one. If the coefficient of friction between the objects and the surface is 0.2. We will follow the divide and conquer method once more. First, we draw a free body diagram for the 2 kg object. Forces applied on this object are force of gravity acting downwards, the normal force acting upwards, the applied force which pushes the object to the right. In a free body diagram, forces always start from the dot and never point towards it. So that's why, even though the applied force is shown on the left side of the object, in a free body diagram, we have drawn it on the right side of the dot. Then there is the friction force opposing the motion, thus acting to the left. We have to draw one more force. According to the third law of motion, if one object applies force on the second one, the second object will simultaneously apply a force of the same magnitude but in opposite direction on the first object. The applied force of 40 newtons is pushing the 2 kg object to the right, and the 2 kg object is also pushing the 3 kg object. As a result, the 3 kg object will push the 2 kg object back with the same amount of force. We will name this force as F21, force of the second object on the first one. According to the second law of motion, the net force is equal to mass times acceleration. We consider the right as a positive direction as the object tries to move to the right. Thus, the friction force and the F21 will have negative value. Friction force is equal to mu times the normal force. And for this question, the normal force is equal to mass times gravitational acceleration. We can apply substitutions now. The applied force is equal to 40 newtons. Coefficient of friction is 0.2. Mass of the object is 2 kgs. And the gravitational acceleration is 9.8. After some calculations, we get the first equation of this question. 36.08 minus F21 is equal to 2 times A. We have now one equation with two unknowns. To be able to solve it, we need one more equation, which we can get from the second object. In a free body diagram, we draw the force of gravity and the normal force as we did for the 2 kg object. The friction force will be drawn to the left as it is opposing the motion. The last force is the force with which the 2 kg object is pushing the 3 kg one. We name it as F12, force the first object exerts on the second one. The net force is equal to mass times acceleration. F12 is to the right and the friction force is to the left. So, instead of F net, we can write F12 minus F is equal to m times A. The friction force is equal to mu times n. And the normal force is equal to mass times gravitational acceleration. Coefficient of friction is 0.2. Mass of the object is 3 kgs. And the gravitational acceleration is 9.8 meters per second square. As a second equation for this question, we get F12 minus 5.88 is equal to 3 times A. In the next step, we bring these two equations together. As we mentioned in the previous questions, even though it is not taught in maths class, it is easier to solve these kind of questions by adding the equations side by side. In the first equation, we have F21, and in the second one, we have F12. As we know, these forces have equal magnitudes. One of them has positive sign, the other one has a negative sign. So if we add equations, these two will cancel each other. 36.08 minus 5.88 is equal to 2 times A plus 3 times A. 30.2 is equal to 5 times acceleration, and the acceleration of the system is 6.04 meters per second square. Now we can substitute this result in one of the equations. In the previous question, we have used the first equation. For this one, let's use the second. F12 minus 5.88 is equal to 3 times A. And we have just calculated the acceleration as 6.04 meters per second square. Force exerted on the second object by the first one is equal to 24 newtons. As force 1-2 is equal to force 2-1, the force applied on the first object by the second object is also going to be equal to 24 newtons. In this question, we have learned how to calculate the action-reaction forces between two objects. In the next one, we will solve yet another type of question. Don't forget to subscribe and turn on the notifications in order to be updated about my new videos.